Hey guys, so today we'll be solving this problem called longest zigzag path in a binary tree. Let's read it. You are given the root of a binary tree. A zigzag path for a binary tree is defined as follow. Choose any node in a binary tree and a direction. If the current direction is right, move to the right child of the current node. Otherwise, move to the left child. Change the direction from right to left or left to right. Repeat the second and third step until you can't move in the tree. Zigzag length is defined as the number of nodes visited minus 1. Correct. Return the longest zigzag path contained in that tree. Right. So in this problem, we've been given a tree and we need to find the zigzag path, right? So longest zigzag path, right? And we've actually uh, taken the first example. So first, what we'll do is we'll see what is the longest zigzag path. So right now, we know that this only has a right child, right? Whereas this has a right child, right? And then it has a left child, and then it has a right child, right? And that is the longest that is possible here. If I start from here, this is the right child, then I need to move left. So there is only two length possible, whereas 1, 2, and 3 length is possible here, right? Um, what is the other option? So I go here, uh, and then I need to go here. And yeah, I mean, that is the possible option, that the second one that I showed you. If I start from here, it will just be 1, right? So that is the longest possible path or zigzag path in this tree, right? Let's take the second example. So if we see in the second example also, we have the longest path starting from the root node and going till the end, right? So it's like we start from here, then we go right, then we go left, and then we go right, right? So which is 1, 2, 3, and then 4, right? So 4 possible longest zigzag path is possible in this tree, right? And that is the idea. How we can solve this is quite simple. We'll actually run a DFS, right? A depth first search at the level of the tree. So at every step, okay, I have two options. One is to either go to the left or go to the right, right? And at every step, I have two options as well. Either going to the left and right, and as well as either I want to start a new zigzag path, right? That is also an option, right? So what I can do is, first of all, at every left and right, zigzag that I do, that I follow through, I have two options, which is go to the left and go to the right. We can continue adding it to the longest path that we have been tracking, or we can start a new path from it, right? So we can maintain a global max zigzag path possible, and also like a current or the local zigzag path, which is also going to be in the DFS, and it will be like a local variable inside the DFS function that we going to run. And from there we have two options, either to update that a local variable, which means that we are using the previous exact path and going forward, or we can always start a new one, right? So that is the idea. Let's get to the coding part in order to understand this better. So in this tree, let's get to the coding part. As I told you, I'll create a maximum path possible, right? And which will be initialized to 0, right? And I will have a DFS function which will have a root, and also we'll maintain a local variable which will be the local path. And also we'll know that if we want to know that there is a left path or right path that we need to follow, right? So that will be a counter that will be maintained. So true is that boolean variable that will be maintained, and return max path, right? Always. Now let's get to the DFS part. In DFS, yeah, obviously we'll be creating a void DFS function, tree nodes, right? And then we'll have a boolean, which is a flag to know that do we need to go left or do we need to go to the right. Starting, it's always going to be, I started with the right, I started with the left part. So that will be go left, and also I'll maintain a steps, right? So now you have two options. If node is null pointer, right? If node is null pointer, I just return from there. do nothing, right? Now I have this max path which needs to be updated as well. So max path is basically max between max path and the steps, that is the local variable, right? Now, as I told you, we have this, flag which says that we need to go left. So if we know that if we need to go left, then I have two options. So either I can start a new path or even just update the previous path that has been coming so far. So I can either go to the left, right, and have this false and steps +1, right? Or I can start a new path. So no left, false, uh, you know, yeah, this will be true because I'm forming a new path, 1, right? Else, I have two options here as well. So DFS node right, and obviously we have gone to the right. So just going to have that as, a new path forming, or I can use the previous path that, hey, I've already considered the right path. Now I'm switching the Boolean variable and also adding the steps +1 here, right? And that is the idea. So that will update the max path, populate the max path with the maximum local steps it's possible, and then return that. Let's run it to see if everything is working fine. Right. So it's giving an issue here, which it says 0, right? 4. Yeah. So on left, then it's false, steps +1. Then we go, yeah. Ah, right. Yeah. So this is something that we made a mistake here. So we have here, yeah, we have two options. So as I told you, we can go to the left or start a new path, right? Starting a new path can have two options. So we can go to the right or we can start a new path from the left, right? So we know that go left. So if go left is present, then we know that we need to go left, right? So go left will do this and add the steps +1, right? And we know that we can form a new path from the right. So node dot right will always form a new path here, in the second line, sorry, here. And similarly here we have to know that because we need to go left is, go left is basically a switch, right? So here the switch is off and we know that we can go to the right now. So left will always form a new path and right will always add the steps, which is the local variable which is already defined there, right? That will run. Let's see if everything is working fine. Cool. Think that that works. um yeah, just took a bit of time. Yeah, that works. Cool. I hope you guys understood the problem. Thank you so much.